All right, this is 49 group anagrams. And essentially this question is you're given a bunch of strings inside of an array. And within those strings are words that are anagrams of each other, right? And you want to group those up together. So here, bat is alone, but nat and tan are anagrams of each other. Ate, eat, and tea are all anagrams of each other. And so how we're going to do this is first we're going to iterate through this list, grab each string, right, individual string. And then after that, we want to grab each individual character. And it's better if I show you through the blackboard, right? So let's go here. We want to grab each string, right? So for S in strings, right, we're grabbing each individual string and we're starting off with eat. And what we want to do is we want to create a count for each character we see inside of eat. So that's how we're checking to see if it's an anagram of each other, right? We grab E, A, and T, and then eventually we're going to check if this one has E, A, and T, which it does, and it's an anagram. So that's what we're going to do. Here we grab each individual word, so each string, right? And then now we're going to create a count. And in this count, how we're going to do it is we're going to have a bunch of zeros, right? And then we're going to have this multiplied by 26, which is the amount of letters in the alphabet. And this is how this would look like. So it would be 0, 0, 0, 0, and then it would keep going, right? You keep going. Now let's leave that there for now. And now we want to iterate through each individual character. So for C in the string, right? C is character, and then S is the string we grab. So essentially S here would be eat, and then C would be, as we're iterating through it, it would be E, A, and T. And what we want to do here, the whole point of this for loop is that we want to initialize this set of zeros with numbers. So let's say we saw E, or in this case, let's start with A, right? Let's say E or 8, right? These zeros represent a letter in the alphabet. So this one would be A, B, C, D, E, and so on, right? And all these letters have an index. So essentially A would be 0, right? And then this would be 1, 2, 3, 4, and so on. And so what we're going to do is we're going to work with the ASCII values of these letters. And essentially, I'll write it out and then I'll start explaining it, right? So then we're going to initialize count. So count at, and then ord is the function to find the ASCII value of a letter. So let's say ord at A. Pretty sure the ASCII value for this is 97, right? So that's going to be our base case. 97 is going to be our base case. And so we're going to grab the character, right? The character here, so at C, and we're going to subtract it by the ASCII value of A, which is our base case. And how would this look like? So let's say we had 8. 8 would be, so the ASCII value of 97, so let's do it like this. So C minus the base case, which is A. And let's say C was A, right? So then we would get 97 minus 97 because A is 97, right? And then this one's also A. And we would get 0, which is the index at the beginning. So it would be the index here, right? And then, so what we want to do is we want to add, so plus equals 1. What this is doing is we saw A once. So then we're going to initialize at index 0, 1, right? So we have 1A. And that's how that would work with all the other letters, essentially. So let's say we have ord, right? Ord C, which is the character inside of the word over here, right? And so we have ord C minus ord A. That's what our code is going to look like. Let's say this was B, right? B minus A, which would be 98 minus 97, which is equal to 1. right? So essentially, as you're going up the alphabet, A, B, C, D, 97 becomes 98, 99, and then that's how you would find the index for each letter inside of these zeros. So that's what we're doing. Every time we see one of the letters, we add one to its corresponding index. And that's pretty much how this code works. And so you're initializing it, right? And then after that, you want to add the word to the hash map, which we should have a hash map here. And so what we're going to do is we're going to do like this. So the result is equal to default dictionary and then list. So what is this doing? Why aren't we using a regular, let me clean up some space here, right? Why aren't we using a regular dictionary here, or a regular hash map? And what is a hash map? So a hash map has keys and then values. That's what a hash map is, right? And these keys are immutable. So that means you can't change them. Unlike lists, you can't change them. They're immutable. Anyways, so we're setting the default to be a list. So let's say we have a key, right? So we're let's say res, and then at A, we want to append 1, right? This spells res, sorry. So what this does is that if the key wasn't already inside of the hash map, it initializes the value to an empty array, right? Instead of, essentially, if you didn't have this here, right? If you didn't have this line of code there, setting the default to a list, you would have to check if this key was already in it. So if not, let's say in the hash map, right? If not in hash map, so this is just pseudocode, right? If not in hash map, then you really initialize it, right, to an empty one, and then you append. That's just a dumbed down version of that, but there's more code to it. But essentially, what this is doing is you're setting the default to a list, so you don't have to do all that extra stuff. And so what we want to do is that, so res, right? You want to, let's see, what are we doing here? So we have the count, we initialize the count to 1, and so we want to set the key to count, right? But count is a list, right? This is a list. And what we want is, as I said before, keys are immutable. So we would have to turn count into a tuple, right? Count. And that makes it immutable, which allows it to become a key, right? You can't change it anymore. Tuples are immutable. And so you would want to set all those zeros, right? All the zeros, and then if you saw a B, it would be 1, and then etc., right? You set that to the string, right? So it would be, let's say, 8. That's just one of them. So you would want to append to it. Now, why aren't we? So it would look like this. So append, and then string. Now, why aren't we just setting it equal to? So let's say here the tuple count is equal to s. Now, why aren't we doing this instead? So essentially what appending is doing is you're just adding onto it, and instead this, you add to it, but you're replacing. If you had a different value there, you would replace it. So it would just get, let's say you had 8. What append does is you would add to it. So eat, right? This would become the new one. But if you had 8 previously, right, and then you want to add, if you do this line of code here, it would just replace it to eat, right? And now that would mess it up. So then that's why we are using append instead of just setting it equal to the next string. So now let's try to type it up so it makes better sense. And essentially how we're going to type it up, right? We're going to start by setting, res, oops, why am I here? We're going to set res is equal to default dictionary and list. So if there is no key value, right, then you just have an empty list. And so let's start by getting each individual string. So for s in strings, and then we want to set the count equal to, let's see, the zeros, and then times the letters in the alphabet. And then you want to start the loop to check for each character. So for C and S. So for each character in the individual string. And after we've done this, what did we do next? So we want to initialize the count, right? So count ord at C, at the character, minus ord at A. Now, A is, you have to set it to the actual individual value of A. Oops. Okay, I guess it just, let's do this. The actual individual value of A instead of a variable A. So this has the value of 97, and then you subtract from any other letter here. And so after doing this, you're pretty much done. That's initializing it. And after you get the count, you want to do res at the count, right? At the count, and you want to set this to a tuple. Right, you set this to a tuple. And then we append the string. Now, each time you're looping through this and you're done appending it, it creates a new count. So and then that one is used for the next individual word. And so at the end, you want to return res, you want to return all the values. You want to return every single value inside of the hash map, right? All of these. Res.values, and you do that by using the values function. And this looks correct. Let's run it. Wrong answer, nats. So then what are we doing wrong here? Oh, we forgot the plus equals, right? Plus equals 1. So now we're adding 1 to every time we see the character. And this should run correct, right? So we have the default dictionary. We're looping through each word, creating a new count each time for each word. You're going through each character, and then you're setting up the count for every time we see the letter. And then here, at count, you're appending the string. And so you're appending, so you're adding on to the previous one if there was a previous one, and then you're returning the values here. All right, thank you.